Okay, so here's the version 2 of the solution to the problem in finding the limit as x approaches 5 of the function x minus 5 absolute value over x squared minus 25. So if the function is an absolute value and you want to find the limit as x approaches a particular number, you have to define the absolute value properly. So what do I mean by that? Okay, take note that if you want to get the limit as x approaches 5, you have to find first what is the limit as x approaches 5 from the left and the limit as x approaches 5 from the right. And from our concept, if these two values are the same, then that will be the value of the limit as x approaches 5. Now for absolute value, we all know that this can take two different values. The absolute value could mean x minus 5 when x minus 5 is greater than or equal to 0. That means x is greater than or equal to 5. Or it can take the negative of x minus 5 when x minus 5 is less than 0, or when x is greater than 5, less than 5. Now, some might ask, like, why is there an equal sign on the x minus 5 when there is no equal sign on the negative of x minus 5? Actually, there are three division for this. The one is with the greater than 0, the one with less than 0, and the one with equal to 0. But we can actually combine the two. So you can put the equal to 0 to x minus 5 of the x minus 5. Or you can also take the equal sign here on the negative x minus 5. So you have to choose. Either you put the equal sign here or you put the equal sign on the second one. It doesn't matter as long as you don't put the equal sign on both. Okay. But anyway, so going back to the limit as x approaches 5 from the left and x approaches 5 from the right, you can now rewrite the function with the by taking away the absolute value. Now to choose which one should be used for the absolute value, you have to consider where the numbers are coming from. Remember that when we say we approach 5 from the left, we are considering numbers on the left of 5. So these numbers. So that means those numbers are smaller than 5. And when you go back to the definition, the value of the absolute value x minus 5 is negative x minus 5 when the x is less than 5. So that means when you replace this absolute value here, it should be the negative of x minus 5. And then just copy x squared minus 25. In the same way, if you want to get the limit as x approaches 5 from the right, you have to choose which one from the two. So obviously, the other option, because this one is for the values that are less than 5. So we change the absolute value x minus 5 to simply x minus 5 over x squared minus 25. But then again, so how do you find the value of these two limits? So the first one will be limit as x approaches 5 from the left. This is negative of x minus 5 all over x minus 5 and x plus 5. So you can cancel this. This will become limit as x approaches 5 from the left of negative 1 over x plus 5. And from here, you can already substitute the 5. This is negative 1 over 5 plus 5, or negative 1 over 10. So the limit as x approaches 5 from the left is negative 1 over 10. On the other hand, this one will become limit as x approaches 5 from the right of x minus 5 all over x minus 5 times x plus 5. So in the same manner, you can cancel this. So this will become limit as x approaches 5 from the right, 1 over x plus 5. Then you substitute 5 to get the limit. So this is 1 over 5 plus 5 equals 1 over 10. So the limit as x approaches 5 from the right is 1 over 10. So going back to the main question, so what will be the limit as x approaches 5? So remember, this value will only exist if the limit from the left and from the right are the same. But obviously, one is negative and one is positive. So they're different, they're not the same, they're not equal, so the limit does not exist. In this kind of problem or this kind of limit, I will not be asking you to identify whether it goes to positive infinity or negative infinity. So for now, it will be enough to say that the limit does not exist because the limit on the left and on the right are not the same. Okay, so the limit does not exist.